Vertiports will play a crucial role in integrating VTOL aircraft into everyday life. To minimize travel times, these vertiports must be flexible enough to be placed in densely packed urban areas. At the same time, safety remains a top priority to ensure that vertiports don't face the same limitations as rooftop helipads in New York City. The regulations discussed in this video are based on the EASA standards for Europe, which are likely to change between the recording of this video and the actual introduction of VTOL aircraft into service. Let's start by looking at the two main categories of VTOL aircraft certification, the enhanced and basic categories. The enhanced category is required for commercial use or operations over congested areas. Aircraft in this category must be able to continue safely to a landing site in the event of an engine failure, whether at an alternate vertiport or their intended destination, and without needing exceptional piloting skills. The basic category is designated for cargo operations or training purposes in less congested areas. Aircraft in this category should be able to perform a safe emergency landing, similar to how helicopters can auto-rotate to the ground in case of an engine failure. In this video, we'll focus on the enhanced category, as it applies to the commercial operations of VTOL aircraft in urban settings. There are three types of takeoffs. The conventional ground takeoff is similar to how helicopters operate. This involves takeoff from a ground-based helipad or, in some cases, a short runway. The elevated conventional takeoff is a regular takeoff from an elevated area higher than 3 meters, such as a rooftop. And lastly, the vertical takeoff. In this method, the aircraft ascends vertically before transitioning to horizontal flight. This is a key feature for urban air mobility, as it allows aircraft to operate efficiently in tight spaces, with minimal runway requirements. The minimum platform size of a vertiport is 1.5D by 1.5D, where D represents the diameter of the smallest circle that can enclose the entire aircraft when viewed from above. These are some of the platform dimensions for the aircraft discussed during last video. As you can see, the Lilium jet requires the biggest platform. The Joby S4 needs a slightly smaller platform, and the Xpeng X2, being more compact, requires the smallest platform. While these regulations are in line to those for helicopters, they aren't always optimal for VTOL aircraft, because these aircraft tend to have irregular shapes, unlike helicopters, which all have the same dominant component for their D value due to their rotors. In addition to the platform size, regulations also govern the space above and around the vertiport to ensure safe vertical takeoffs and landings. This obstacle-free volume helps to prevent buildings, trees, and other structures from interfering with aircraft movement. Every VTOL aircraft will have slightly different procedure volumes due to the varying takeoff and landing dynamics of each model. There are two types of procedure volumes, directional and omnidirectional. The directional procedure volume is designed for aircraft that always follow a specific approach and departure path. It begins at the 2D by 2D pad, extending upward by 3 meters, before sloping outward to form a rectangle that's 3D wide and 4D long, at a height of 30 meters. No obstacles are allowed within a 12.5 degree gradient along the aircraft's approach path until an altitude of 152 meters is reached. It's important to note that these dimensions represent the reference volume. This is a volume given to provide clearer guidance, which reflects the most likely dimensions that will be applied when building vertiports. Additionally, when viewed from above, the directional obstacle-free volume expands outward to 7D wide during the day and up to 10D wide during nighttime operations, ensuring safe approach and departure paths under various conditions. The omnidirectional procedure volume, which is slightly more complex, is designed for a vertiport that allows for approach and departure routes from multiple directions. This is likely to be used in busier vertiports, where multiple approach paths are necessary. However, even in omnidirectional volumes, certain areas may be blocked. In such cases, the volume is not truly omnidirectional in practice, but adapted to the specific conditions of the vertiport. To go from the procedure volume to the full obstacle-free volume, a safety margin is added around the entire procedure space. This ensures a buffer between the aircraft's route and any potential obstacles. Here are some examples of the directional obstacle-free volumes for the Lilium jet, Joby S4 and Xpeng X2. As you can see, these volumes fit neatly into relatively compact spaces, making them practical to implement in real-world urban environments. On the other hand, omnidirectional volumes, designed for more congested vertiports with multiple approach paths, naturally require more space due to the additional flexibility in aircraft movement. One significant advantage of VTOL aircraft is their ability to take off from rooftops, making them easier to integrate into cities, since placing them at higher altitudes reduces issues with the obstacle-free volume. This way, vertiports can be placed in urban areas without major restrictions. Additionally, this opens the door to innovative designs where the vertiport includes a stack layout, with lounges and waiting rooms situated directly beneath the pad, maximizing the use of limited city space. While vertiports are a critical component of the VTOL ecosystem, several challenges remain before these aircraft can be fully operational. Nevertheless, we are closer than ever to a future where VTOL aircraft transform urban travel. Vertiports will play a key role in determining whether these aircraft become a mainstream mode of transport, offering faster, more efficient travel from point A to point B. If you've enjoyed this video, don't forget to like and subscribe to stay updated on the latest developments in urban air mobility and the exciting challenges we'll need to overcome as VTOL aircraft become a part of our daily lives.